For topic two, we're going to look at problem solving. Okay, so steps used in problem solving. So keep in mind in math, a lot of times when you see the word application or you see the word problem solving, it doesn't always mean this, but it will frequently mean word problems. Okay. So part of the issue is just understanding what the problem is asking. So sometimes you have to read the problem and maybe you have to read it multiple times, but read it to get just a firm grasp of what they're asking you to do. Okay. Translate the problem. This can sometimes be the hardest part. This is where you do the actual algebra. We're going to assign variables to unknown values. We're going to build equations. Okay. Part three is solve. Once you have the equation, solving usually isn't terribly difficult. Okay, so we want to solve the problem, perform whatever operation is indicated. Estimations can sometimes be used to get an idea of what the actual solution might be. Okay, so sometimes if you sort of think about it, you can be like, okay, the answer should be somewhere in, this ballpark. And so once you solve, you can kind of see if you're in the right area or not. And then finally, interpret the results. This is something that you have to be really mindful of. Once you solve the equation, you're not necessarily done. Okay, so once you solve the equation, you have to relate everything back to the word problem. And then sometimes you have to do some extra work to find other additional values. Okay. So this is sort of like where you start. This is a good general strategy for solving word problems, okay? Now, for us, we're going to start kind of easy. We're going to start with just really the basic direct translation like we did in the previous video. We're going to go ahead and solve these, though. We're not just going to find the equation. We're going to find the equation, and then we're going to practice our skills at solving again because we'll need those skills in the last example, okay? So example three says translate each sentence to an equation and solve. We're going to let x represent the unknown number. So for part A, it says 5 times a number decreased by 3 is equivalent to the difference of twice a number and 18. So our variable is going to be this unknown number that is going to show up twice, okay? We also need to understand that is equivalent to is going to be the equal sign. So everything in this sentence that comes before is equivalent to is going to be the left-hand side of the equation, and everything that comes after the phrase is equivalent to is going to be the right-hand side of the equation. So let's build, okay? On the left, we have 5 times a number. That just means we want to take whatever this unknown number is, which remember, we're going to let x represent the unknown number. We're going to take that number x and we're going to multiply it by 5. And in algebra, that is like super easy. You literally just write them side by side. Actually, I'm going to scoot this over a little bit more to make sure I have plenty of room to solve. So we get 5 times a number, and this is going to be decreased. That means subtract. It's going to be decreased by 3, so we're going to subtract 3. And then this is, we have the point where we're at is equivalent to, so that's going to be our equal sign. And this is all equivalent to the difference of, so that means subtract, the difference of twice a number. So twice a number, we just take 2 times x. And then from that, we have a difference. So remember, difference means subtract. So from twice a number, we want to subtract 18. And this is our equation. So we have 5 times a number decreased by 3 is equivalent to the difference, so subtract, of twice a number and 18. Okay, so really take some time to understand how this equation relates back to the sentence and how the sentence relates to the equation. Okay, now we want to solve. So we're at a point where each side of the equation is as simple as it's going to get. We have at most 2 terms on each side. In fact, we have exactly 2 terms on each side, and each side contains 1 variable term and 1 constant term. Once you get to that point, you know you can start applying your properties. So we want to apply the addition property of equality to do 2 things. It is going to get the variables on one side of the equation and then the constants on the other side. So let's start with this 2x on the right. I want to move it to the left. Since 2x is positive, I think of that as plus x. And the way we undo addition is with subtraction. So we're going to subtract 2x from each side. Whoa. So that's going to give me on the left 5x minus 2x is 3x. Drop down your minus 3 and your equals. And then on the right-hand side of the equation, 2x minus 2x is just 0, and then 0 minus 18 is negative 18. Okay? Now, I've got my variables in a single term all on one side of the equation, but I want to isolate that term. I want to get the 3x term alone. My issue now is this minus 3. So how do we undo subtraction? Well, we use addition. So we're going to add 3 to both sides. Okay? Well, on the left, negative 3 plus 3 is just 0. 3x minus 0 is just 3x. And then on the right, hopefully we're getting better with some of this like basic subtraction with signs, but we have negative 18 plus 3. When we're adding two numbers that have different signs, we want to find the difference in the positive and the negative. So we really secretly subtract. So 18 minus 3 is 15. But now we have to determine the sign. And so the way we do this is we ask ourselves, what did I have more of? Did I have more of the negative or did I have more of the positive? Well, at this point right here, we have negative in the term, or we have 18 negatives. I can't even speak. So we have 18 negatives, but we only have 3 positives. So that means we have way more negatives. So this is negative 15. And then I'm going to move this up here just so I have room to finish solving. So we have 3x equals negative 15. So we're at the point where we have a single term on each side of the equation. One side is a variable, the other side is a constant. We need to apply the multiplication property of equality to get the variable alone, okay? So essentially what that means is we need to undo the multiplication of 3 and x. So we undo multiplication with division. So we're going to divide each side of this equation by 3. Well, on the left, 3 goes into 3 one time, leaving me with just 1x. And then on the right, 3 goes into negative 15, negative 5 times. So this blue unknown number has a value of negative 5. Okay? Whew, there's a lot of talking, I tell you. Okay? Now, finally, for part B, we have 3 times the difference. Be so very careful. If we had the difference of 3 times a number, that is very different than 3 times the difference of something, okay? Here, we want 3 times the difference. So that means we want 3 times an entire difference. Keep that in mind. So we want 3 times the difference of some unknown number and 1, okay? And that's going to equal 12, okay? So everything before equal in the sentence is going to be the left-hand side of the equation, and everything after equal is going to be the right-hand side of the equation. So let's focus on the left. So we have 3 times an entire difference. So that difference is going to go inside parentheses, and we're going to multiply each part of it by 3. And the difference is going to be between a number and 1. So we get 3 times the difference, x minus 1, and that's going to equal 12. Okay, so we want to solve this one, and in this case, we do need to distribute. So we're going to start with 3 times x, which in algebra is really easy. You just write them side by side. 3 times x is just 3x. 3 times negative 1 is negative 3, and that all equals 12. Now, I want to get my 3x alone. We're in a really good spot here. The left-hand side has 2 terms. One is a variable term, one is a constant term, so I can't simplify that. The right-hand side is just a constant term. I've got all of my variables in a single term, so now what I need to do is isolate the variable term. So I want to get my 3x alone. The issue is the minus 3. Okay, we need to move the minus 3, and in order to do that, we need to undo it from the left. So we undo subtraction with addition. So we're going to add 3 to both sides, okay? Well, on the left, negative 3 plus 3 is 0. 3x plus 0 is just 3x. And then on the right, 12 plus 3 is 15. And I do this sometimes. I don't even mean to, but I just like seem to magically pick problems that have very similar setups. So we've got a 3x and a 15 again, so that's going to make this easy. Now we need to undo the multiplication of the 3 and the x. We want to get the x alone, okay? So to undo the multiplication, we divide each side by 3. On the left, 3 divided by itself is just 1, so 1 times x is just x. And then on the right, we have 15 divided by 3. Positive 15 divided by positive 3 is positive 5. So we have figured out what the value for a number is. It has a value of positive 5. Okay, so hopefully that was a good enough reminder on our steps to solve equations. So now we're going to dive into the actual word problems, okay? So example 4 says translate each scenario into an equation and solve. And we need to make sure that we solve and we answer the question that's being asked. We want to include units or at least a very brief description with our answers too, okay? So part A, let's see. Part A was definitely me watching The Office because we have Jim and Pam. I think the other ones don't have names. So anyway, so part A, we have that Jim and Pam saved $56. Jim saved $8 more than Pam saved. How much did each person save? Well, here's the thing. If you're dealing with something like this, where you've got kind of small numbers, you can sort of play around, do some guess and check, a little bit of trial and error, and you can figure out how much each person saved. But keep in mind, we're in a chapter all about algebra. So at this point, I am your algebra teacher, or whoever your classroom teacher is. They're your algebra teacher. What we're grading is your algebra. So don't do guess and check. Don't do trial and error here. We want to see the algebraic setup. So we want to see you translate each scenario into an equation, and then we want to see you solve it, okay? So no tricks here. Do the algebra. So here's how I do it. And I have a very particular setup. You do not have to use my setup, but you need to show some kind of a setup, okay? So for me, I start with just words and I start with like a vertical setup. For me, it just works easier vertically, okay? So we know that Jim and Pam were both saving money. So if we take the amount Jim saved and add it to the amount that Pam saved, we know they saved a total of $56. Okay, so I start with just really basic words. So the amount Jim saved plus the amount Pam saved has to be $56. Okay, and then once I get something like that set up, then I really start thinking about, okay, where does my variable go? We always assign the variable to what we know the least about. Okay, so assign the variable to what we know the least about. To what we know the least about. So when we go back to the problem and we kind of read for clues, we're going to have some information about one of the pieces and not really some information about the other piece. So we are told that Jim saved $8 more than Pam. We have a clue about how much money Jim saved. We don't really know much about Pam. So because I know less about Pam than I know about Jim, I'm going to say that Pam saved X dollars. Okay, so I'm assigning the variable to the amount of money that Pam saved. Okay, and then I'm going to use that to create an expression for how much Jim saved. Okay, so we know that Pam saved X dollars. Okay, we also know that Jim saved the same amount that Pam did plus eight more than that. So Jim saved $8 more than Pam. So that means he saved Pam's amount, so X dollars plus eight more than that. Okay, so Pam saved $8, Jim saved X plus $8. We can now combine like terms vertically and we'll get an equation that we can solve. So I'm going to bring down my equal sign and then I'm going to combine the expressions for how much Jim and Pam each saved. So Jim saved X dollars, Pam saved X dollars. That's a total of 2X. And then we also have this constant plus 8. So I now have this equation right here that I can solve, and it'll give me the value for X, and I can figure out that's going to tell me how much money Pam saved, and then I can use that to figure out how much money Jim saved. Okay. And this is a situation where my equation is always going to have the variable on the right. It's not really a big deal. Okay. At the end, I always move my variable back to the left. We like to have the variable equal some number, so I'll take care of that kind of at the end. Okay, so when you do this setup that I have here, you generally end up with a pretty much simplified equation. So you just have to do the addition property of equality and the multiplication property of equality. So what I want to do is I want to get my two x's alone. Okay, I've got this variable term. I've just got the one variable term, which is nice, but I need to isolate it. So my issue is the plus 8. How do we move plus 8? Well, we subtract. So I'm going to subtract 8 from both sides. On the left, 56 minus 8 is going to be what? 48. And then on the right, 8 minus 8 is just 0. And then 2x plus 0 is just 2x. Okay? So we've isolated the variable term. We have it equal to a constant. Now we need to isolate the actual variable itself. So this means we need to undo the multiplication of 2 and x. We undo multiplication with division. Okay, so on the left, we get 48 divided by 2, which is 24. On the right, 2 divides into 2 one whole time, so we just get 1 times x or x. So this is when I translate and I move the variable to the left. I don't like saying 24 is x. I like saying x is 24. And I know that seems subtle, but it's just one of those things in algebra. So x is 24. Okay, now you're not done. All right. The question didn't say, what is X? The question didn't say, how much did Pam save? The question said, how much did each person save? So at this point, I just check. Okay. I know that X is 24. And then I know that Jim saved X plus $8. So Jim saved 24 plus $8, which would be $32. Okay. And then I want to add these two values up to make sure they really do add up to 56. Okay. So 2 plus 4 is 6. 3 plus 2 is 5. Everything checks out. Okay. So we could then just write a very brief sentence explaining your answer. So I would say something like Jim saved $32 and Pam saved $24. Okay, you don't have to give me like this long, drawn out explanation, just a quick description of your answer, and it's great. Okay, now remember, you're in a class that's covering algebra. We want to see your algebra. We want to see you build the equation, and then we want to see you solve the equation. Okay. Now, part B says a 12-foot board is cut into two pieces. Okay, the longer piece is 3.5 feet longer than the shorter piece. What is the length of each piece? So again, I start with just a really basic setup with words. I then decide what my variable is going to be, and I build an equation, and then I solve. So we're going to take the long piece plus the short piece, and we know if we were to glue these two pieces of this board back together, they have to equal the initial 12-foot board. Okay. Now, I said earlier that we always assign the variable to what we know the least about. So in this case, what do we know the least about? The board that's longer or the board that's shorter? Okay. We are told that the longer piece is 3.5 feet longer than the shorter piece. So that means they've given us a hint about the longer piece. We know less about the shorter piece. So we always assign the variable to what we know the least about. So we don't know how long the shorter piece is. We just know it's X feet. Okay. Now, if the shorter piece is X feet, and we know that the longer piece is 3.5 feet longer than the shorter piece, then we know the longer piece is the same length as the shorter piece plus 3.5 feet more. So we have expressions now to represent each piece of this equation, the longer piece, the shorter piece, and we know that if we add the length of the longer piece and the shorter piece, they have to equal 12. So let's go ahead and add the algebra and see what that equals. So I have two x's, and then I have this 3.5. So I now have an equation that I can solve. If I solve this equation for x, I'll get the length of the shorter piece, and I can use that to find the length of the longer piece. And then we can check to make sure that the two lengths really do add up to 12 feet. Okay? So I've got 12 equals 2x plus 3.5. I've got a single variable term, which is fantastic. I need to isolate it now. So the issue is plus 3.5. So I want to undo that addition of 3.5. So I'm going to subtract. Well, let's see, 12.5 minus 3.5. 12 minus 3 is 9. Subtract half a foot more, that's going to be 8.5. And on the right, we're going to get the 3x or 3.5 minus 3.5. That's just going to be 0. And then we get 2x plus 0. Okay, so I've got a single variable term on the left. I've got a single, or on the right, I've got a single variable term on the left. I can now apply the multiplication property of equality. So I want to undo the multiplication of 2 and x. So we undo multiplication with division. On the right, 2 divided by 2 is just 1. So that leaves me 1 times x. And then on the left, 8.5 divided by 2 is going to be 4.25. And you are not done yet. Yes, you have solved the equation, but you have not answered the question. So let's go up here and just do some check. We're going to check our work. We know that x is 4.25. We know that x plus 3.5 is going to have to be 4.25 plus 3.5. Well, 4.25 plus 4.25 plus 3.5 is going to be 7.75. So that tells me the length of the longer piece of this board is going to be 7.75 feet long. The smaller piece is 4.25 feet long. Let's just make sure that all adds up to 12, okay? So we start adding, our decimals are already lined up. So we're going to go 5 plus 5 is 10, carry a 1. 7 plus 1 is 9, plus 2 is, nope, 7 plus 1 is 8, bless my heart, plus 2 is 10. So we keep a 0, carry a 1. 7 plus 1 is 8, 8 plus 4 is 12. Drop down your decimal point, everything matches, everything checks out. So we could say the long piece is 7.75 feet, and the short piece is 4.25 feet. Okay, so you want to make sure you include units. So 7.75 feet, 4.25 feet, and give a very brief description of your answer. Your reader should not have to go digging through your work trying to find an answer. It should be like laid out for them, really, really clear. Okay. So part C, consecutive whole numbers. Okay, so consecutive whole numbers, that means whole numbers that are in a row. So like if you're consecutive 3 days, or if you're consecutive, if you're sick 3 consecutive days, you're sick 3 days in a row. Okay, so when you talk about consecutive whole numbers, they're just whole numbers. That means no decimals, no fractions that are in a row. Okay, so we have the sum of three consecutive whole numbers is 18. Find the numbers. So here's my setup for consecutive whole numbers, or sometimes you'll see these called consecutive integer problems, okay? So we're basically dealing with three unknown numbers, okay? But we can't have three variables because we only know how to solve equations when one variable is involved. So what we do is we let x equal the smallest number, or sometimes I'll call it the first number. So I'm going to take my first whole number, I'm going to add it to my second whole number, I'm going to add that to my third whole number, and I know the sum of these three numbers has to be 18. So if I add these three numbers up, I'm going to get a sum of 18. So now we need to assign a variable. And I already told you with these problems, very specifically consecutive integers or consecutive whole numbers, go ahead and assign the variable to the smallest. It just makes the math easier. So I'm going to go ahead and say, okay, I know nothing about any of these numbers really, but I'm going to let x equal the first number. Well, let's do a little side work and just kind of explore. So let's say we have three consecutive numbers. Let's say we start with 11. The next number would then have to be 12. Then we would have to have 13. So we have three consecutive whole numbers, okay? Well, if I say the first whole number is x, how would I algebraically, using an x, write the second whole number? Well, to get from 11 to 12, I would have to add 1. So I would take and say that this is then x plus 1. Okay? Well, how in the world would we write 13 using x? Okay, well, we know that x is 11, and to get from 11 to 13, I would add 2. 11 plus 2 is 13. So I could take the value for x, or for 11, which is x, and then just add 2 to that. So you start with your first integer or your first whole number. It's just going to be a plain old x. And then you just add increments of 1. So you add 1 to x, and then you add 2 to x, and then you could add 3 to x, and then 4 to x, and then 5 to x, and you keep getting the next integer in line. Okay, so my second integer is going to have to, or whole number, is going to have to be x plus 1. And then the third one is going to have to be x plus 2. So now when we combine like terms, we know this has to have a sum of 18, but let's figure out what all of our algebra is going to add up to. Well, we have x plus x plus x, so that's 3x, and then plus 1 plus 2, which is going to be just plus 3 when we simplify. So now we have a nice, easy equation to solve. And honestly, I think we just solved this one in the previous example. It may have looked a little different. I think we had 3x plus, or 3 times x plus 1 maybe, but very similar here, okay? So I want to get my three x's alone. Okay, I've got a single variable term. I need to isolate it. My issue is this plus 3. So how do we undo addition? Well, we use subtraction. So let's subtract 3 from both sides. Okay. Well, on the left, 18 minus 3 is 15. On the right, 3 minus 3 is 0. 0 plus 3x is just 3x. So I've got a single variable term equaling a single constant. At this point, I want to undo the multiplication of my variable and its coefficient. So I need to divide both sides by 3. 3 divided by 3 on my x term on the right. Well, 3 divided by 3 is just 1. 1 times x is just x. And then 15 divided by 3 is 5. So this is now the third problem in this video where we had 3x equals 15. I'm really sorry about that. Okay, but at least you get a lot of practice. So what is 15 divided by 3? Y'all, it's 5. Okay, now let's check this. Let's make sure everything really works out. Okay, so we know that x is equal to 5. So if x is equal to 5, that means x plus 1 has to be 5 plus 1, which is 6. And x is still 5, so that means x plus 2 is 5 plus 2, or 7. Let's add these numbers up. So starting from the bottom going up, 7 plus 6 is 13. 13 plus 5 is 18. So everything checks out. And we just want to write some really quick statement to describe our final answer. We would say something like the whole numbers are 5, 6, and 7. And that's it. Okay? So I think consecutive integers or consecutive whole numbers, they're pretty easy problems. They're not like the hardest thing ever. All right. Now, finally, let me erase this right here. Okay, so finally we have a high school graduating class is made up of 542 students. So we know total 542 students. All right, they are, bleh, I can't read. If there are 56 more girls than boys, how many boys are in the class? Okay, so we want to set this up just with words. Okay, so we know we have a grand total of 542 students. We know that it's going to be comprised of boys and girls, so we're going to say the number of girls plus the number of boys has to equal 542. Okay, so now we want to assign a variable, and we assign the variable to what we know the least about. Okay, so look for a hint about one of these two components. Okay, so we're told that there are 56 more girls than boys. So that tells me I know something about the girls, I know less about the boys. So I'm going to let the boys be X of the graduating class. So X of the students are boys. And then we know that there are 56 more girls than boys. So if we take the number of boys and then add 56, we get the number of girls. So it's going to be X plus 56. Okay. And then we just want to combine like terms. So we have X plus X. Well, that's 2X. And then we have nothing to combine with our 56, so we can just drop it down. Okay. So we have 542. 542 equals 2x plus 56. We've got a pretty straightforward equation to solve here. I've got a single variable term. I would like to isolate it. So I need to start by subtracting 56. So just for the sake of time, 542 minus 56, we get 486 on the left. And then on the right, 56 minus 56 is just 0. 2x plus 0 is just 2x. So now I've got my single variable term equaling my single constant term. I need to undo this multiplication of 2 and x. So I divide both sides by 2. 2 divided by 2 is 1. 1 times x is x, and we're going to get what, 243? All right, so x equals 243, which is the number of boys in this graduating class. So let's just check things out right here. So we get 243. So then the number of girls is going to be X, which is 243, plus 56, which is going to be what, 299? Let's add that up and see if we get the desired final total of what, 542? All right, so let's see. 9 plus 3 is 12, so I keep a 2. I carry a 1. 9 plus 4 is 13 plus 1 is 14. So I keep a 4, I carry a 1. 2 plus 2 plus 1 is 5. Everything checks out. So we could say the class consists of 299 girls and 243 boys. All right. So that is problem solving with these really basic linear equations, okay? We're not expecting you in this class to do anything outrageous, but we do want you to be able to set up an equation that represents some kind of a scenario and then solve it, okay? And just make sure that you answer the questions being asked, because a lot of times when you solve the equation, you're not done. So you need to take whatever you get for your solution, relate it back to the problem, generally find another quantity or two, and then just make a very, very brief description of what your answer is. Okay, so that's it. That's it for this chapter. That's our algebra chapter. I think it was super fun. I hope you enjoyed it. Our last chapter is going to be geometry. So it's going to be kind of a pretty good shift, but it'll be fun.